Space has always represented the ultimate frontier, vast, empty, and seemingly boundless. So when confronted with an ever-growing mountain of waste that has nowhere left to go, it's tempting to look upward and ask the obvious question: why not simply launch it all out there? A planet with no trash, a solar system with plenty of room. It sounds almost elegant, but the moment you begin doing the actual math, the idea starts to look less like a solution and more like the most expensive mistake in human history. Humanity produces roughly 2 billion tons of solid waste every year. To put that in perspective, the heaviest rocket ever launched, NASA's Saturn V, could carry about 130 tons of payload into low Earth orbit. Launching a single year's worth of global trash would require approximately 15 million Saturn V launches. The entire history of human spaceflight has logged fewer than 6,000 launches in total. We are not talking about an engineering challenge. We are talking about a category error. Then there is the cost. Launching 1 kilogram of material into orbit currently runs somewhere between $1,500 and $10,000, depending on the rocket. At the lower end of that estimate, a single year's global waste bill would come to around $3 quadrillion, a figure that dwarfs the combined GDP of every nation on Earth. Even if launch costs fell by a factor of 1,000, the economics would remain hopelessly broken. But suppose, for the sake of argument, that cost and logistics were somehow not the issue. Where exactly would all of this trash go? Leaving it in Earth's orbit is not a disposal plan. It's a catastrophe in slow motion. Low Earth orbit is already alarmingly crowded with defunct satellites and debris fragments. Adding billions of tons of garbage would trigger what scientists call the Kessler Syndrome, a chain reaction of collisions generating ever more debris, eventually forming a permanent shell of wreckage that makes any future space activity, satellite launches, crewed missions, communications infrastructure, effectively impossible. The deeper you push the waste into space, the worse the problems become. Sending trash toward the sun sounds appealingly final, but any rocket misfiring or miscalculation along the way could scatter toxic, radioactive, or biologically contaminated material across unpredictable trajectories. A single failed mission could rain debris back down on Earth at catastrophic velocities. And launching radioactive waste, nuclear rods, medical isotopes, contaminated materials, aboard a rocket that has any meaningful probability of exploding on the launch pad is a risk profile that no serious engineer would endorse. There is also the question of what we would be doing to the solar system itself. Interplanetary space is not a void without consequence. Debris released in heliocentric orbits can travel for millions of years, intersecting with other planetary bodies. We would, in effect, be exporting our pollution problem to a cosmic scale, one that future civilizations, or whatever comes after us, would inherit. The environmental cost on the launch end is no smaller. Rocket propellants release black carbon and reactive chemicals directly into the upper atmosphere, where they linger far longer than ground-level emissions and contribute to ozone depletion in ways that are still poorly understood. Scaling launches to millions per year would transform the atmosphere long before the first garbage bag cleared the exosphere, which brings us back to the ground, where the actual solutions have always been waiting. Reduce what we produce, recover what we can, and incinerate the rest in facilities capable of turning waste heat into electricity. It is considerably less dramatic than a rocket launch, but it is also considerably less likely to end in catastrophe.